Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to go over writing and evaluating algebraic expressions. All right, my friends, so you know there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book. That's the one with our robot friend on the front. Second, you're going to need your math notebook so you can take beautiful notes and keep track of all of your great math thinking. Third, you're going to need a pencil. And fourth, last but never, ever, ever least, that positive math attitude. All right, my friends, so this video goes really well with lesson 4-1, which of course is in your Envision book. The key concepts for this lesson can be found on page 200. And my friends, the majority of this lesson should really be review from 6th grade. What we're doing is we're looking at those algebraic expressions and we're going to be solving some of them. But before we get into some super cool fun math, let's just go over the basic parts of an algebraic expression. All right, so I'm thinking this probably looks pretty easy for you, and it should. But this is like an olden fashioned way of doing algebraic expressions. Like you did this like in kindergarten, right? Where you had a known number, in this case 10, and then you had like a mystery amount. Maybe sometimes it was just a blank. Perhaps it was like a question mark that was here, and then it gave you some answer, right? And then you had to figure out, well, 10 plus what mystery number would equal 12? And of course, you know that our mystery number here is 2, right? Did you know this is algebra? Yeah, you've been doing algebra since like 1st grade, my friends, right? An algebraic expression is just any expression that has an unknown, right? A piece that you don't know. But how could we write this like as an algebraic expression the 7th grade way? So my friends, we know now that as 7th graders, instead of just having a box or a blank or a question mark, we use variables, right? And those variables, which we represent by using a letter, that stands for our unknown amount, right? At this point, do I know what M is? Not really until I look at my answer and then I subtract, right? And I'm able to figure out that M is equivalent or equal to 2 in this case, right? So again, you've been doing kind of like this setup, this idea for like a long time. But now let's see what like the 7th grade kind of like beefed up algebraic expression looks like. All right, so I'd like to look at this algebraic expression so that we can talk about the different pieces that are inside of it so that we know what makes this an algebraic expression and how we're supposed to go about solving it, right? So we have 4w plus 8 divided by 2 minus 10, all right? Lots of stuff going on, but let's break it down. All right, my friends, the first thing that I want to look at is this w right here. That is our variable, right? That means that it's an unknown amount at this point. And of course, you probably noticed we do not currently have enough information inside this algebraic expression to help us figure out what this variable stands for, right? That's why we're using the letter w to kind of be a placeholder for whatever that actual value is, right? So w is our variable. And along with that variable, we also have a coefficient, which happens to be the number 4 in this case. Now, a coefficient only goes with multiplying the variable. 8, not a coefficient. 2, not a coefficient. 10, not a coefficient. Why? Because it's not being multiplied by their little variable buddy, right? So a coefficient has to go with that variable, and it has to be being multiplied by that variable. The next word I want to talk about is the word term. Term. You can think of a term as a part or a piece, right? Each term is a part of our larger algebraic expression, but there's 2 operation signs you need to be aware of: the addition sign and the subtraction sign. These are the signs, my friends, that separate these different terms. Not multiplication, not division, only addition and subtraction. So if I'm thinking about, well, how many terms is even in this algebraic expression? There's 3. I have 4 times w, that's 1, plus, so again, this signifies that we are now going to our next term. 8 divided by 2, believe it or not, that's just 1 term in of itself, right? 8 divided by 2. Now, if this was 8 plus 2, that would separate it to a different term, correct, my friends? But it's division, not addition, not subtraction, right? And then I notice I have a subtraction sign, which again tells me I'm about ready to go into my third term, which is subtraction, right? Subtracting that 10. So again, my friends, a term are like those pieces, those parts of our larger algebraic expression, but they have to be separated by either addition or subtraction. Just a quick note, terms does not mean the number of numbers or the number of operation signs that you have inside that algebraic expression, right? You're looking for pieces that sometimes can have more than one number and sometimes might have an operation inside of it, right? Always make sure that you're looking for that addition or subtraction sign to help you figure out where your terms are. All right, so now that we have a little bit of background about what makes an algebraic expression, let's start putting this into practice. So the first example I'd like to look at together is on page 200, and it's number 6. Now you'll notice in this problem, I have a coefficient, right, with a variable. Yeah, coefficients can also be fractions. They can also be decimals. Pretty cool, right? So we have 3/8 times my variable, which is x, minus 4.5 or 4.5. Notice we have two terms in this expression. We have 3/8 x, right? 3/8 times x, that's term 1. It's separated by that subtraction sign. The second term is then 4.5, right? For 2 terms. I have a little bit more information in this as well. It tells me that x is equivalent, or x is equal to 4/10, right? Now, really quick, my friends, you might notice we got a fraction, we got a decimal, and then we got another decimal, all right? Now, there's 2 different ways you can go about solving this. One, you can keep them all as decimals. You could keep them all as fractions. And guess what? You're going to get the same answer. So let's solve it both ways. All right, my friends, so what I did in these 2 examples was I first noticed that x is equivalent to 4/10. So I took that value, my friends, and I plugged it into my algebraic expressions, right? I substituted it for x. Why? Because I know that they're equal, okay? Over here, I converted everything to fractions. So we have 3/8 times 4/10. Notice that's inside my little parentheses because I need to do that piece first before I subtract 4.5. Now on this side, I converted everything to decimals. So 3/8 is equivalent to 375 thousandths, right? And we're still going to multiply it by that 4/10. And then after that, right, it's in parentheses because that piece needs to come first. Then we are going to be subtracting 4.5. Remember, my friends, you can solve it either way, fractions or decimals, and you're going to get the same answer. So how should this look while we're solving it? So your first step over here in fraction land, right, is to multiply 2 fractions together, 3/8 times 4/10. Now remember, my friends, when we are multiplying fractions, the most beautiful thing in the world is we don't need to worry about converting them to like or common denominators, right? All we do is we multiply the numerator straight across, the denominator straight across, and then boom, we got our new fraction, right? So 3/8 times 4/10 is equivalent to 3 times 4 over 8 times 10. So what's your final product? All right, my friends, so when we did all that fun math, we found that 3/8 times 4/10 is the same as 12/80ths, but we know we can simplify that, and when I do, I pull out that common factor of 4, I'm left with 3/20ths. So my final step over here, my friends, is then to subtract 4.5 from 3/20ths. Now remember, since we are subtracting a larger number from where I'm starting, my answer should be negative. So your final answer should be, my friends, so when we do all these calculations, we have 3/20ths minus 4.5, and that's going to equal a negative 4 7/20ths. Again, this is keeping everything as fractions, but now let's check out the decimals. Right, so over here at our decimal side, notice we have those parentheses, right? So the first part that we need to do, my friends, is to take 375 thousandths and multiply that by 4/10. So what's your answer from inside this parenthesis? So from inside the parentheses, once we've done that fun multiplication, we find that our answer is 1/1500ths, right? But I'm not done because I still need to subtract that 4.5. And when I do, my final answer should be Final answer should be -4 and 35 hundredths. And here's a super duper cool thing, my friends. Did you know that -4 and 7/20ths and -4 and 35 hundredths, those are equivalent, my friends? Don't believe me? Use your calculator, take 7 divided by 20, and I guarantee you your answer is going to be 0.35. All right, my friends, so the next one that I'd like to look at together is still on page 200, but now it's number 7, all right? Now you'll notice a few different things. One, we just have decimals here, so no worries about having to convert to fractions. Yay, right? We have two coefficients. We have 8 and 4/10. That's a coefficient with its little BFF n over here. We also have 3 and 2/10 as a coefficient with its little buddy, the letter p, or the variable p over here. Now, a couple things. Remember, we have two terms in this expression. We have 8 and 4/10 n, that's term 1. It's separated by that subtraction sign. And then our second term is 3 and 2/10 p, right? So two terms here, both a coefficient with a variable. But, my friends, notice, n and p, those do not have the same values. Yes, I know it says they don't have the same values over here, but remember, if they had the same value, then they'd have the same variable, right? So I know that I am not multiplying 8 and 4/10 by the same number that I'm multiplying 3 and 2/10 by. Why? Because different variables will have different values, right? So always keep that in mind. But I do have some more information that I can use to solve this, correct? I know what the value of n is. I also know what the value of p is. So now, my friends, I'm going to rewrite this algebraic expression, but I'm going to plug in those values that I have. All right, my friends, so once we put in those values that we have, our new expression, our new algebraic expression, 8 and 4/10 times 2, right? I need to do this piece first, and then I will subtract it from 3 and 2/10 times 4. So now let's do our multiplication on both sides. All right, so my friends, once I have performed this multiplication, I find that 8 and 4/10 times 2, 8 and 4/10 n, is actually equivalent to 16 and 8/10. Likewise, 3 and 2/10 times 4, or 3 and 2/10 p, is equivalent to 12 and 8/10. Don't forget, we're not done quite yet because we still need to subtract the two. So your final answer would be equal to 4. Very nice job, my friends. You just went from an algebraic expression, you plugged in the values that you had, and you're able to come up with a final answer. Awesome. And so there's one more example I'd like to look at together. It's on page 201, and this is number 9. Now, the reason I chose to go over this one is because, yikes, there's 3 fractions. We got to multiply some fractions, then we got to add some fractions. It's all right. You can do it because you're big, beautiful, and brilliant. Of course, you can handle like little fractions. Don't even worry about it. So let's look at the pieces that we have of this expression. We have 1/2 times t plus 3/8. Notice I have two terms, right? 1/2 times t, that's term number 1. It's separated by that addition sign, and my second term is 3/8, right? So 2 terms. I only have, sadly, 1 coefficient, and in this case, my coefficient is 1/2 because that is the only number that is being multiplied by my variable, which at this point is t. But we got more information, my friends, right? Our lovely Envision book told us that t, our variable, is actually equal to 1/4. So now I have enough information to plug in that value and actually solve it. So, all right, my friends, so the very first step that I did is I rewrote this algebraic expression, but instead of having t as my variable, I substituted 1/4 for t because that's what I was told the value was, right? So now I'll actually have 1/2 times 1/4 plus 3/8. And of course, orders of operations, we need to do that multiplication first. And remember, just like we did in that other example, I love multiplying by fractions because it's so easy peasy lemon squeezy, right? You just multiply the numerators, multiply the denominators. So your product would be 1/8. So again, 1/2 times 1/4 is 1/8. But we're not done yet, my friends, because we still need to add that last term. And you know that sometimes adding and subtracting fractions can kind of be a headache because you have to do like conversions to like denominators. But the math stars have aligned, my friends. Look at this. Already got a common denominator. So awesome, right? So now all I need to do is just add those numerators, those numbers on the top. And remember, when we're adding or subtracting fractions, the denominator, stays the same. So 1/8 plus 3/8 is going to be equal to, so 1/8 plus 3/8 is equal to 4/8, which we know we can also simplify as 1/2. Right, my friends. So again, that was just a quick run through of writing and evaluating some algebraic expressions. And as always, if you have any other questions, please let me know.